Hello all. So far we have discussed about what attention mechanism is all about and how do we implement attention mechanism to the sequence to sequence model, and we've also studied about self-attention and transformers, right? So today in this session I would like to discuss about transfer learning. As all of us know what transfer learning is all about. We have been studying this concept since we have started our machine learning journey, right? So we have seen what transfer learning is in the concept of machine learning and deep learning. So transfer learning in simple, I say it is the application of skills, knowledge or any other attributes of one model or situation to another model, right? So transfer learning is basically a technique wherein a model developed for one task can be used for developing another task taking the starting point of the model of the first model, right? So why do we need transfer learning? Basically, this approach will leverage the knowledge gain of one task and we apply the same to the other task. Okay, so transfer learning is particularly useful when the data set for the target task is very small or insufficient to train a model from the scratch. So instead of wasting time on developing new model related from the scratch, we go for transfer learning technique wherein we apply the models. Okay, when you look into this particular task, I'm applying transfer learning, right? So I have taken two tasks here. One is driving a bicycle and writing with hand, right? So if I have the basic knowledge on driving a bicycle, I apply the same skills on to driving a scooter. So the basic idea of driving would be taken from task A. The remaining changes, whatever are applicable, will be applied to task B, right? In the similar manner, when I look into other task of communication, I'll try to write by hand, and that would be same like typing on the keyboard if I knew the alphabets. So the knowledge of alphabets and the words would be carried forward on typing on the keyboard with some changes, right? So when I talk about ML models, what is the difference between ML models, or how can we add this to the domain? Okay, so when I talk about self-driving cars, if you have knowledge on how do we operate self-driving cars, then I can easily operate self-driving trucks with some changes. So I'm gaining the knowledge from self-driving cars and apply that to self-driving trucks. So this is all about transfer learning. So when you look into the concept or implementation part of this, if suppose I have an image of a car and I have to recognize this, so we basically use a CNN model, right? So we try to learn the features, we apply pooling layers, and then we do feature extraction, apply convolution layers, pooling layers, and we apply the probabilities of Mac function, and then we'll decide what image is that, whether it is car, truck or bicycle. When it comes to transfer learning, when I have new data, I will not extract the features or apply the features to the new model, but what I do is I take this pre-trained CNN is already trained, right? So from the first figure I take that pre-trained CNN and I apply that to the new task or new image that I am getting. Okay, so when I talk about this, as you can see on the left hand side of the figure, so when I get the input, I pass the input through the convolutional layers, pooling layers and all that to the custom layout CNN, and I take the output. But when it comes to pre-trained model, I take the existing model, that is pre-trained model, and use that in the new model. Okay, so when we talk about traditional machine learning, before this advent of pre-trained models have come into existence, that is transfer learning has come into existence, we used to train model based on task wise we used to train the model. So one model for task 1, task 2, task 3 and so on. Okay, so lots of amount training time, and then domain adaptation was difficult when we go for traditional method of transfer learning. Hence we go with this concept called transfer learning, which has three important concepts. So transfer learning covers these three major aspects. One is pre-training would be done, fine-tuning, okay, and then feature transfer also will be done, domain adaptation also would be done with transfer learning. Okay, so all of us know what pre-training is, right? When a model is trained on already existing large general data set with respect to some patterns or representation, we can use this model for developing other applications. When I talk about fine tuning, the pre-trained model which is developed can further divide it into specific data set, or you can make your own changes of fine tuning the model to improve the performance of the new model, right? So when I talk about feature transfer, the initial layers of the neural network often generate features such as edges, patterns, shapes of the images or textures as well, right? So by using these layers, we can design the model which can quickly adapt to new tasks with fewer training examples, right? So when I talk about domain adaptation, okay, domain adaptation, this involves adapting a pre-trained model to new domain, as we have seen in the example, driving a truck and driving a car. Okay, so here the data distribution differs from the original training domain, but with minimum discrepancy, we change the techniques between source and target domains. So these are the three important things which are covered with transfer learning: pre-training and fine-tuning, feature transfer, and domain adaptation. Okay, so covering all these 3 points, the transfer learning is basically of 2 steps. Okay, so I call transfer learning as a machine learning model which is first trained on one task. Okay, it will be trained on one task which is called as pre-training, and after that it is adjusted and used in another task which is called as adaptation. So if the same model is used for both tasks, the second step would be fine-tuning. First we pre-train, fine-tune, and then use it for domain adaptation. Okay, as you can see, it is pre-trained on the large text corpus. This pre-trained language model with some fine-tuning adaptation can be used for another task. Okay, now when I talk about this concept called domain adaptation, it is closely related to transfer learning. It is basically a technique where you train the machine learning model in one domain. For example, when I talk about text classification, news data segregation from social media data, it is all about text classification. The task is same, but the data or domain, here the domain is news, here the domain is social media. Okay, so this is all about the basic concepts of transfer learning. Now when I talk about types of transfer learning, we have 3 important basic types. One is called as inductive transfer learning, transductive transfer learning, and unsupervised transfer learning. Okay, now if the source and target task are different, the source and target tasks are different, but the domains are same. For example, classifying medical images. When I talk about medical images of lungs, medical images of kidneys would be different, right? But the domain is same, medical images, but the task is different on different organs. So this is called as inductive transfer learning. Now, when I talk about the second one, it is transductive transfer learning. Okay, here the source and target tasks are same, but the domains are different. For example, adapting a spam detection model trained on English emails to detect spam in French emails. Okay, so here the domains are different, but the task is same. That is spam detection. The domains here are English emails and French emails. Okay, the third type of transfer learning technique is unsupervised transfer learning technique, where both task and domains are different, but there's no label data in the target domain. Okay, so here in this case we use pre-trained language model to generate text in low resource language and then apply that to the new task. Okay, so these are 3 different types of transfer learning techniques. Okay, now when we talk, this is the generalized understanding of what transfer learning is all about. Now when I talk about transfer learning in NLP, okay, so transfer learning has significantly impacted many different NLP applications by enabling the models to perform with more accurate results. Okay, because the models are already pre-trained. Okay, so when I talk about transfer learning in NLP, we use pre-trained word embeddings. We have seen word to vector, we have seen glove. Both of them are pre-trained word embeddings. We will see contextualized word embeddings, Elmo and BERT models that we're going to see in the next sessions, which are word embeddings which are contextualized. Okay, and then we also have transformer based language models which also use this transfer learning techniques. For example, GPT-2 T5 model, text to text transformer. Okay, so all these models are also based on transfer learning techniques. Okay, now what are the advantages? When you talk about different advantages of transfer learning, basically the model is already pre-trained and applying the same knowledge onto the new model, so which reduces the training time. Okay, the pre-trained models have the fundamental knowledge on all the patterns, all the data that is being taken or read already, trained already. So reducing this, using this methodology, we have reduction in time or extensive training from the scratch can be observed. Okay, so leveraging knowledge from a large data set will obviously improve performance of the task with the limited data. So we can have improved performance when we go for transfer learning techniques. Okay, so by using transfer learning, the resources also can be used efficiently when you try to train the model from the scratch. Okay, enhanced generalization is another advantage, that is models can generalize better new tasks and domains by reusing the learned features. Okay, so this is all about the basic concepts of what transfer learning is and where do we use transfer learning in the context of NLP. Thank you so much.